Hi everybody, and welcome to Black Holes and Time's End, a sleep-inducing journey, your cosmic lullaby through the darkest places in the universe. Above you, the sky stretches out like deep velvet. The stars are scattered embers, soft and silent. There's no breeze in space, no birdsong, no traffic, no neighbors arguing at 2 a.m., just the hush of emptiness. But not nothing, because hidden in that silence are invisible traps, massive, elegant, monstrous. Black holes. You float gently past nebulae glowing in pastel pinks and ghostly blues. Below you, a star, bloated and dying, trembling like a candle in its final breath. Then, a sudden, silent collapse. In seconds, its core falls in on itself, vanishing behind an invisible curtain. The black hole is born. You feel it before you see it. Gravity whispers at your spine, curling around your ankles, beckoning. It's beautiful, in a terrifying way. A pinprick of nothing pulling in everything. No light escapes. No screams either, though that might just be because there's no air in space. You drift closer, entranced. You reach for your flashlight, but the beam bends, pulled sideways. Even light can't disobey. Somewhere, a scientist is sipping tea and muttering equations. But you're floating into myth, into mystery, into something older than planets and smarter than your best Wi-Fi. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, drop a comment with your city and local time. I love seeing where in the world you're listening from. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You close your eyes, and the black hole watches you back with its event horizon, a silent border between knowing and never knowing. They don't look like anything. That's part of the trick. No glow, no outline, just absence. Yet black holes shape galaxies, devour stars, and bend the very fabric of time. You imagine space like a bedsheet, and the black hole a marble pressing down. But this marble has no bottom. The sheet tears. Long ago, before Netflix, before the wheel, even before cheese, people looked up at the night sky and wondered what lay out there. But no ancient stargazer could have imagined this, a region of space where physics folds in on itself like origami dunked in black ink. Still, you drift closer. You pass Pluto. It's still confused about its planetary status, and wave at Voyager 1 as it chugs along with its golden mixtape for aliens. Beyond that, space becomes quieter, colder. Time itself stretches like taffy. Here, in the black velvet dark, you understand something unspoken. Black holes aren't just objects. They're rules. They define where things end. Stars can explode and scatter. Planets can crumble and drift. But black holes, they stay. And yet, they weren't always here. You picture a star, a massive one, maybe 30 times the mass of our sun. It shines fiercely, burning its fuel like a teenager chugging energy drinks. It knows its time is short. When its core runs dry, gravity wins. The star collapses, pushing in, until not even atoms can resist. What's left is tiny and infinitely dense, a singularity wrapped in darkness. No surface, no crust, no floor to stand on. Just endless inwardness. And now it waits. Astronomers map the skies, noting the orbits of stars that seem to circle nothing. That nothing is often a black hole, quietly anchoring systems, lurking at galactic hearts, minding its own horrifying business. They come in sizes, too. Stellar mass black holes, you've just met one. Intermediate mass ones, still mysterious. And supermassive ones, which are just showing off. But regardless of size, each is a gatekeeper of time and space. There's an old theory. Some fringe thinkers say black holes are actually doorways to other universes. That if you slipped past the event horizon, you'd be reborn somewhere strange. Others laugh at that. You'd be spaghetti, they say. Nothing else. Historians still argue whether early 20th century astronomers truly believed black holes were real or just wild math hallucinations. But here you are, floating near one, watching starlight curve like a slow-motion waterfall around it. The temperature drops. Not because it's cold. There's no temperature in space. But because you feel it. A chill from knowing you're in the presence of a cosmic apex predator. Silent, elegant, always hungry. But you're not afraid. Not really. Because tonight, you're just a dreamer gliding along the edge of the unknowable. And the black hole? It's waiting. You're still drifting, pulled gently but relentlessly toward the dark. There's no wind, no sound. Just the faint thrum of your heart sinking with the rhythm of distant gravitational tides. It's time to ask the question every sleepy traveler eventually does. What the heck is a black hole, really? On paper, it sounds simple. A black hole is a region in space where gravity is so intense that nothing, not even light, can escape. But of course, it's never just that simple, is it? If it were, we wouldn't be having this little bedtime story moment with the most terrifying thing in the known universe. You stare at the spot where a star once lived. Now it's a hole in space, but not like a tunnel or cave. No walls, no inside, just absence. Imagine deleting a pixel from a photograph, and then having that missing pixel pull in all the others around it. That's a black hole. The term black hole itself wasn't coined until the 1960s by physicist John Archibald Wheeler. Before that, these cosmic beasts were called frozen stars, or more ominously, collapsed objects. Somehow those didn't quite sell tickets to sci-fi conventions. But Wheeler's phrase stuck, and let's be honest, it sounds way cooler. Still, the concept goes back further. In 1784, an English clergyman and scientist named John Michell had the audacity to imagine a star so dense, its gravity would trap light. He called it a dark star. You can almost picture him, sipping tea, staring into the fireplace, and casually inventing horror in the cosmos. Historians still argue whether Michell's ideas were ahead of their time or just speculative nonsense. Either way, he basically guessed the central feature of black holes 2 centuries before we had the physics to prove them. Not bad for a guy without Wi-Fi. But here's where things get slippery. A black hole isn't a thing in the way a chair or donut is. It's a region of space. It's defined not by what's in it, but by what can't get out. Like a trapdoor that won't let you return once you step across. That border? It's called the event horizon. And what lies within the horizon? The singularity. Yeah, that word again. You'll hear it a lot. It's a fancy way of saying, all the rules break here. Scientists say a singularity is an infinitely small point with infinite density, which is another way of saying, we honestly have no clue, but the math went full bananas here. You pause. A flicker of starlight grazes the edge of the event horizon and curves around it, lensed and distorted like you're peeking through cosmic glasses. You wonder, if not even light can escape, how do we see black holes? Clever question. The truth is, we don't see the black hole itself. We see the effects it has on its surroundings. Stars whipping around nothing, gas spiraling into an invisible drain, heating up as it vanishes. Light getting warped, gravity bending time. Black holes leave fingerprints everywhere, just not where you'd expect. And then, there's gravitational lensing. Light from objects behind the black hole gets bent and focused like a magnifying glass. The result? A warped halo of light, the closest thing to a silhouette the universe can offer. You begin to realize that black holes aren't just destructive, they're sculptors of space. They bend paths, twist time, warp reality. And yet, they obey the same physics that governs falling apples and awkward roller skate accidents. There's something strangely polite about it. Despite being the ultimate cosmic vacuum cleaners, black holes follow rules. Einstein's equations describe them neatly, at least until the singularity, where everything turns into theoretical soup. Speaking of Einstein, he never really liked black holes. His equations predicted them, yes, but he found them distasteful. Like someone writing a recipe and then going, ugh, no, don't actually cook that. He even co-wrote a paper in 1939 arguing that black holes couldn't form. Spoiler alert, they can. The universe does not care about your feelings, Albert. Fringe thinkers once suggested black holes might actually be white holes from a different side of the universe, ejecting matter instead of sucking it in. No one's found one yet. But in a universe where octopuses exist, who knows? Your eyes adjust again to the dark. The stars seem farther away now. Or maybe it's you drifting closer to the heart of this mystery. You remember that feeling you had as a kid, when you first stared into the deep end of the pool and couldn't see the bottom. That's what a black hole is. The deep end of the universe. And it never ends. Even now, as you float in the quiet, your mind tries to grasp the ungraspable. How can something be so dense that it becomes invisible? How can time slow down just by moving closer to it? And who, exactly, decided this was bedtime material? But as the blackness stretches and curves, you feel a calm curiosity, like peeking into a locked door, knowing full well it won't open, but being captivated anyway. You're not falling in. Not yet. But you are learning. And somewhere, the cosmos is gently clapping for your curiosity. Or maybe that's just the sound of distant quasars applauding. Either way, you're doing great. You float in the silence, the stars a little dimmer now. Space stretches around you like a soft, endless quilt, cold to the touch, full of hidden stitching. But tonight, your attention drifts back in time. Way back, to the moment black holes are born. Because no black hole starts as a hole. It starts as a star. Not just any star, though. Not your polite, sun-type star that heats your toast and occasionally flares up in solar tantrums. We're talking about titans, giants, stars so massive that they burn through their fuel faster than a college student through energy drinks during finals. You float closer to one of these behemoths. Its surface churns in golds and reds, raging with nuclear fire. It's massive, perhaps 20, 30, even 50 times the mass of our sun. You watch it struggle to hold itself together. It wants to shine, but gravity wants to crush it. It's a cosmic tug-of-war. Inside, the core is cooking heavier elements. First hydrogen, then helium, carbon, neon, silicon, until it hits iron. And here's the twist. Iron is useless. The star can't get any more energy from it. It's like hitting a wall at full speed. And when the fuel's gone, gravity wins. Instantly, the outer layers collapse inward at astonishing speed. The core implodes. Temperatures spike to billions of degrees. Shock waves ripple outward. The star doesn't go quietly. It explodes in one final, furious death scream called a supernova. You feel the blast, even now, like thunder rumbling across the universe. And then, silence. Where the core once was, there's now a pit in space. A black hole, born not with fanfare, but with a soft snap as reality gives way. This process, stellar collapse, has created the majority of known black holes. They're like cosmic tombstones, marking where massive stars once burned. But not all stars go this way. Smaller stars, like our sun, get to retire peacefully as white dwarfs, dim, cooling embers. Others collapse into neutron stars, tiny but dense, like packing a mountain into a teaspoon. But if the mass is just right, or rather, just wrong, gravity doesn't stop. It crushes the core past even neutron degeneracy. That's when you know a black hole's been born. Here's a historical snack. The first indirect evidence of a black hole came in 1964. Astronomers noticed a star in the constellation Cygnus moving oddly, tugged by nothing. That nothing turned out to be Cygnus X, one of the first widely accepted black holes. Fun fact, Stephen Hawking bet another physicist a subscription to Penthouse magazine that Cygnus X, one wasn't a black hole. He lost. Publicly. Gracefully. With cosmological style. Historians still argue whether early black hole skeptics were simply cautious, or just couldn't stand the idea of nature having a delete button. You turn your gaze toward a field of stars. Somewhere in that glittering spread are thousands of stellar corpses, many of them unseen. Silent black holes drifting through space, undetectable unless they interact with something. You realize, most black holes are invisible not because they're hiding, but because they're lonely. Nothing nearby means no feeding, no radiation, no drama. Just perfect, quiet isolation. Honestly, kind of relatable. Occasionally, a star wanders too close to a black hole. You watch one now, a gorgeous blue giant drifting into the gravitational maw. Tidal forces stretch it, then tear it apart. The gas spirals inward, heating up and lighting the black hole's surroundings in a halo of X-rays. You think, it's like a firework display before the finale. And yet, the black hole remains unchanged. The matter vanishes. The mass increases. But the event horizon, the outer edge of the black hole, simply grows a little, like a shadow expanding. Remember, a black hole has no surface. You don't land on it. You just go in, cross a boundary you can't uncross. And here's a fringe-Y theory for your pillow. Some scientists speculate that collapsing stars don't create singularities at all. Instead, they may form Planck stars, a hypothetical, ultra-dense core where quantum gravity holds everything in place. It's still very speculative. But hey, bedtime's for big dreams and bigger questions. Right now, you're watching the universe recycle itself. A star dies. Its atoms scatter. Planets are vaporized. And out of that chaos, a new thing is born. Not just a remnant. A black hole, quiet, unseen, but carrying the memory of everything it consumed. You begin to notice the time. Not your own time, but cosmic time. Stars live for billions of years. Black holes, potentially trillions, or more. They don't just outlive civilizations. They outlive atoms. In a sense, they are the universe's retirement plan. Your body relaxes in this knowledge. Stars may scream as they go, but black holes, they just arrive, with finality, and you're still drifting, on the edge of a death that creates something eternal. Still floating, still weightless, still unbothered by things like calendars or deadlines or that suspicious noise your fridge has started making. But now you're staring at something abstract. A formula, a shape, a hole in space, explained with math. You're drifting back in time, again, but this time to 1915. Picture a German soldier in World War I, not crouched in a muddy trench, but hunched over notes and equations. His name, Karl Schwarzschild. He'd just read Einstein's freshly baked general theory of relativity. Most people would have said, wow, okay, and gone back to their day job. But not Carl. He sat down, between artillery fire, mind you, and solved the field equations for a perfectly spherical mass. That solution? The first mathematical description of a black hole. Although no one knew it at the time, the Schwarzschild radius was born. You're floating beside it now, like a moth next to an invisible bonfire. It's the distance from a massive object center at which, if you shrink it down enough, the escape velocity equals the speed of light. You cross that radius? But bye. No returns. Let's say you wanted to turn the Earth into a black hole. All you'd need to do is compress it into a ball about 9 millimeters wide. That's smaller than a marble. A cosmic horror marble. Fun at parties. Awkward at funerals. The Schwarzschild radius depends entirely on mass. A black hole with the mass of the Sun? Roughly 3 kilometers wide. Double the mass, double the radius. Simple, clean, terrifying. You try not to think about it too hard, because it's spooky how little you'd need to change for everyday objects to become black holes. That chair you're sitting on, if compressed enough, it'd have its own tiny Schwarzschild radius. It's not going to collapse, of course, unless the laws of physics completely short-circuit in your living room. Historians still debate whether Schwarzschild truly understood what he'd discovered. After all, the term black hole wouldn't exist for another 50 years, and Schwarzschild himself wouldn't live to see the theoretical implications. He died in 1916, just months after sending his results to Einstein. The universe kept his secret a while longer. Back in the present, you float past swirling models, space-time curving like sheets stretched by invisible hands. You see light rays bend and orbit a central point. You sense gravity pulling not just objects, but time itself. The math shows it. Time slows near a black hole. You watch a glowing clock approach the Schwarzschild radius. Its hands tick slower, slower, and then stop, at least from your perspective. The object itself continues falling. But to you, it's frozen at the edge. This is called gravitational time dilation. It's not science fiction. It's not poetic metaphor. It's just what gravity does. And yes, Einstein predicted that too. Probably while sipping tea and confusing everyone at the faculty lounge. Here's a quirky tidbit. The actual Schwarzschild solution describes a non-rotating, uncharged black hole. But in the real universe, most black holes do spin and have some electrical charge. So the Schwarzschild solution is kind of like modeling a perfect sphere in geometry class. Beautiful, elegant, and not exactly how things work in nature. Still, the Schwarzschild black hole is where the idea began. The cleanest model. A perfect thought experiment. You drift next to one now, a lonely sphere of influence, completely invisible, outlined only by the glow of bent starlight and falling matter. You reach your hand out. Not that you should, but in dreams, you can do anything. There's no resistance, no wall, no surface, just space, and then, not space. As soon as your fingers touch the horizon, they're lost. No signal, no light, not even a metaphorical oops. You're not torn apart yet. That comes later, but you are officially gone, at least to the outside world. This edge, the event horizon, is the Schwarzschild radius in action. Named for the event you'll never witness, because no event inside it can ever send a signal out. You could host the most spectacular fireworks display known to the universe just past the event horizon, and not a single photon would escape to tell the tale. You feel small now, and weirdly peaceful. It's strange how mathematical something so terrifying can be. A black hole isn't an evil monster. It's just geometry. It's just the shape space-time makes when it gets overwhelmed by mass. And like all beautiful things in the universe, it comes from a strange intersection, a dying star, a brilliant mind, and math scribbled during a war. You let the formulas drift by, soft and glowing like snowflakes. Tensor calculus never looked so lovely. And the best part? You don't have to understand all the equations to appreciate the feeling. Like standing at the edge of a cliff, not because you want to jump, but because the view is unbelievable. You're floating closer now, closer to the edge, closer to where gravity stops playing nice. The black hole looms before you, not a swirling vortex like Hollywood promised, but a perfect sphere of silence. No color, no texture, just absence. And in this absence waits your fate, spaghettification. Yep, that's the real word scientists use. Sounds delicious, isn't? Let's set the scene. You're falling feet first into a stellar mass black hole. At first, you barely notice anything. The stars keep glowing. Time seems normal. But as you drift closer to the event horizon, things get weird. Your feet are slightly closer to the center of the black hole than your head. That means gravity pulls on them just a tiny bit harder. No big deal on Earth. Big deal here. The difference increases rapidly. Your body stretches. Not all at once, slowly, like taffy. First, your spine extends. Then your muscles thin. Your bones lengthen. Your atoms realign. You are, quite literally, being pulled into a string. A spaghetti noodle made of van. Your horizontal width? That gets compressed. The same force that stretches you also squeezes you in from the sides. You're becoming a cosmic linguine, long, narrow, and profoundly unfit for dinner. But don't panic. If it's a supermassive black hole, the tidal forces at the event horizon are much gentler. You might cross it without even realizing. The spaghettification doesn't begin until deep inside. How thoughtful. Fringe theory time. Some physicists argue that you might never actually feel anything at all. From your point of view, everything seems fine. Until, very suddenly, it's not. Others suggest the process could be instant, as quantum effects rip you apart at the tiniest scales. It's kind of like falling asleep and waking up in an exploded diagram of yourself. Historians still argue whether the term spaghettification should have been taken more seriously when Stephen Hawking popularized it. Spoiler, scientists ran with it. Because even the terrifying needs branding. Now, to an outside observer, you're frozen. Not like, Elsa can't let it go frozen. We're talking relativistic freezing. Time dilation means anyone watching you fall and sees you slower, until you stop at the event horizon. Forever teetering. Never quite falling. But from your perspective, you fall straight through in seconds. No delay. No hesitation. No, are you sure you want to continue? Pop up. You've crossed the line. The event horizon is behind you now. There's no coming back. There's also no up, no down, no sideways. Space is warped. Time is twisted. Directions have meanings only Einstein would appreciate. The singularity waits ahead. You can't avoid it. All paths lead there. You could try to turn, to twist, to claw your way out, but the geometry won't allow it. Not because you're weak, but because nothing can escape. Not even light. Not even dreams. And here's the haunting bit. From the moment you cross the event horizon, all future paths end at the singularity. It's not just a place, it's a time in your future. As inevitable as Tuesday morning. Imagine if every road on Earth led to the same point, and you had to arrive. That's what a black hole does to space-time. It rewrites the map so there's only one destination, the end. There's something almost poetic about it. You came from a star. You're being pulled into what remains of one. And in that journey, you experience not just destruction, but a transformation of time, space, and self. Even now, as you're being stretched thinner than the plot of a daytime soap opera, there's beauty. Starlight bends in luminous arcs. You glimpse the galaxy warped into halos. Your heartbeat slows, not because you're scared, but because the rules are changing. You're inside an Einstein painting now. Curves, loops, angles that don't make sense. A place where the laws of physics come to party, spill drinks, and forget their own names. And just before the pain kicks in, if pain even means anything here, you wonder, is this death? But no, death requires time. You don't die in a black hole. You dissolve into something else. Something the universe hasn't bothered naming yet. As your atoms unwind and your mind fogs into quantum noise, you feel strangely at peace. No regrets. No Wi-Fi. No pressure to answer texts. Just endless falling. Endless stretching. Endless wonder. The black hole cradles you. Not gently, but with cosmic indifference. You are now part of its mass. Part of its history. A small increase in its gravitational pull. A faint whisper added to its story. You've been spaghettified. And somehow, it's kind of beautiful. You've crossed the line. The event horizon is behind you now, somewhere far back in memory, like the last daylight before entering a cave. The stars are gone. So is direction. There is no sky here. No floor. Only the curve of space. And it's curling inward, like a spiral staircase that never stops turning. You've entered the region beyond physics. Beyond light. Beyond return. And here, inside the point of no return, everything starts to feel wrong. At first, it's quiet. Not peaceful quiet, like a library or snowfall. This is the weightless kind of quiet. The kind where not even time can be trusted. Your body still exists, probably, but you can't feel it. There's no breeze, no pressure, no sensation. Only a strange awareness of falling without motion. You remember those amusement park rides, the ones that drop suddenly and leave your stomach in a different zip code. This is like that, but gentler, deeper, and infinite. If anyone out there were watching, they'd still see you frozen at the event horizon, stuck in time like a paused video. But from your point of view, you're falling freely. No pain, no resistance, just a slow, irresistible slide toward, well, something. And here's where things get weird. Or weirder. In normal space, time and space have clearly defined roles. You move through space. You exist through time. But inside a black hole, those roles begin to switch. Time becomes your prison. Space becomes your fate. It's as if every step forward must end at the singularity, not because of distance, but because it's now the future. You're not moving toward it. You're becoming it. You don't have a choice. No one does. Once you're inside, the singularity isn't just a place you might visit. It's the only future that still exists for you. Fringe thinkers, always the fun ones at science parties, have suggested that the inside of a black hole might be another universe entirely. That the singularity could be a bridge, not an end. Maybe you're being pulled into a big bang somewhere else. A cosmic handoff. But maybe not. Historians still argue whether early black hole models underestimated just how strange the interior would be. Even Einstein avoided the subject. The math gets ugly. Complex numbers, infinities, things dividing by zero. The kind of math that makes chalkboards spontaneously combust. You pass a moment where space curves back onto itself. Not like a loop you can walk around, but like a hallway that narrows forever without ending. It feels claustrophobic. You wonder how something infinite can feel so tight. Even light behaves differently in here. It doesn't escape. It circles, spirals, vanishes. You try to shine a flashlight, but the beam twists away like it's being chased by something. You blink. Did your hand even move? The singularity waits. It's not ahead in the traditional sense. It's just inevitable. Every moment you spend here, you're pulled deeper into a place where your atoms no longer agree on where they are. Your body stretches, memory flickers, identity goes fuzzy. What's you now anyway? Matter? Thoughts? Gravity doesn't care. The singularity isn't picky. There's a theory, just one among many, that the singularity is a point of infinite curvature. That space and time become so warped they effectively end. Not because they break, but because they simply run out of places to go. You try to imagine it. A point smaller than anything. Containing everything you were. Everything the star was. Everything the black hole has ever consumed. All squashed into one impossible dot. A dot that exists in a place with no where. At a moment with no when. It's like a cosmic delete key. But instead of erasing you completely, it presses save as somewhere, in some form. Maybe you're just reorganized. The truth is, no one knows what happens at the singularity. Our math breaks. Our language fails. Even imagination gets blurry. Inside this final chamber of gravity, the universe keeps its last secret. You could be data, you could be dust, you could be recycled into something no telescope has seen. But here's the gentle trick. You'll never feel it. Not really. Time stretches so much as you fall that, to you, the singularity is always just ahead. Like chasing the end of a dream. You never reach it. You become it. And outside, the black hole keeps spinning. Quiet, patient, heavy with the memory of your fall. Someone, somewhere, might detect a faint pulse of radiation. A whisper, a loss of mass. And in that whisper, you live on. Because nothing ever really vanishes in the universe. It just changes form. And you, now part of the most mysterious object in the cosmos, are still part of the story. Falling, stretched, remembered. Outside the black hole, time ticks on. Stars orbit, galaxies collide. Bored aliens probably scroll through cosmic social media. But inside, you are memory now. A whisper beneath gravity. A pattern rearranged. And yet, the black hole remembers you. Not your name, not your favorite cereal, but your mass, your spin, your electric charge. It's called the no-hair theorem, and despite sounding like a tragic barber accident, it's actually one of the weirdest rules in astrophysics. According to the no-hair theorem, once something falls into a black hole, it loses all its identity. Not just personality, everything. The only things the black hole keeps are how much mass it gained, whether the thing was spinning, what charge it had. That's it. That's all the universe lets it remember. No hair, no scars, no signature, no YouTube watch history. It's like feeding a vending machine that only cares about the weight of the coin, not what country it's from. Once you're in, your individuality is lost. You are smoothed out. And that leads to one of the most brain-breaking mysteries in modern science, the information paradox. If everything that falls into a black hole gets erased, doesn't that violate the laws of quantum mechanics? Because quantum theory says information, like what state particles were in, can't be destroyed. It's fundamental. Even if something burns, evaporates, or explodes, the information has to go somewhere. But if black holes delete it, well, that's a problem. This little conundrum kept physicists up at night for decades. It's like the universe threw out its receipt and now can't prove it ever bought the matter in the first place. Enter Stephen Hawking. In the 1970s, Hawking did something wild. He combined Einstein's theory of gravity with quantum mechanics and discovered that black holes aren't completely black. They radiate. This radiation, now called Hawking radiation, is incredibly faint, but it means black holes slowly lose mass over time. They evaporate, fade, disappear. And here's where your sleepy brain should perk up. If a black hole can vanish, what happens to the information it had swallowed? If it's truly gone forever, that breaks physics. If it's somehow encoded in the Hawking radiation, well, that changes everything. Historians still argue whether Hawking himself believed the information was lost or just hidden. He changed his stance late in life, suggesting that maybe, just maybe, the information leaks out, like ink through a sponge. But no one has proven it. You, floating in imagination, try to picture this. A black hole, steaming away like a distant kettle. Over trillions of years, it shrinks. Smaller, fainter, and finally, poof, it's gone. But where are you? The bits and particles that once formed your body? Are they encoded in those last dying photons? Or were they scattered across dimensions? There's another theory, of course there is, that black holes store everything that falls in on their event horizon, like a cosmic hard drive. The idea, called the holographic principle, suggests that the 3D world inside the black hole might actually be fully described by 2D information painted on its boundary, like a hologram, or a pizza box that secretly contains the recipe for everything inside the crust. It's elegant, ridiculous, beautiful, possibly true, maybe not, but you can't help feeling that somewhere, the universe knows, that your fall, your stretch, your spaghettification, it wasn't wasted. It left an imprint, a ripple, a faint, gravitational sigh that will echo until the black hole itself fades into silence. There's comfort in that. Even in erasure, there is memory. Even in silence, there is shape. And now, you imagine the far future. Not just next year, not just next galaxy, but the end of time. Black holes, like you, are patient. They wait. They outlast stars, planets, even atoms. They're the universe's final archivists, holding on to matter long after everything else has cooled and faded. Eventually, after unimaginable stretches of time, they evaporate fully. Hawking radiation steals their last whisper of mass. They pop out of existence with the quiet grace of a bubble in a bathtub. But even then, maybe, just maybe, the information remains. Scattered in the quantum foam, painted in the background radiation, coded into the heartbeat of space itself. So no, maybe you weren't lost. Just rewritten. And isn't that what the universe does best? Time slips. You don't notice it right away, but it's stretching thin now, like taffy left too long in the sun. You're hovering outside reality's deepest well, watching as the very idea of time begins to fade. The black hole is still there, of course, unmoving, silent, majestic, but around it, things are changing. Not with explosions, not with sound, with stillness. Galaxies continue their slow ballet across the cosmos, but inside a black hole's influence, nothing is ever the same. This is where you start to feel the time trick, where a second here might be a century out there. If you could hover safely just outside the event horizon, don't try it. It's not exactly wheelchair accessible. You'd see time behave like a stubborn sloth. Everything beyond you would race forward. Stars would age, planets would crumble, civilizations might rise and vanish, all while your watch barely ticked. It's called gravitational time dilation, and yes, Einstein predicted it too. Honestly, it's getting a little suspicious how often he was right. Someone should have checked his homework more often. Time dilation is why black holes might work like cosmic time machines, but only in one direction. Forward. You can't go back. You can't loop. But you can wait. Hovering near a black hole, a few hours could pass for you, while billions of years unfold for everyone else. Think of it as the ultimate nap. You wake up and the whole universe is different. Not bad for avoiding awkward family reunions. And yet, this isn't science fiction. This is real physics. Tested. Observed. We've seen this play out with GPS satellites, which tick slightly faster than clocks on Earth due to both their velocity and their distance from Earth's gravity well. Engineers must correct for relativistic time dilation, or else your phone might think you're ordering pizza from the moon. Historians still debate whether early physicists appreciated just how flexible time really is. Newton thought it was absolute, ticking along uniformly, like a perfect metronome. But Einstein came along and said, actually no, time is local, personal, conditional, and we've never looked at clocks the same way again. You float deeper into this concept, wrapped in the thought that time, something so everyday, so predictable, can bend, warp, stretch, and even stop, depending on where you are. Black holes show us that time isn't just a line, it's a fabric. And when gravity gets heavy enough, it pulls that fabric into folds and knots. This is why, for anything falling into a black hole, the journey becomes a strange blur of paradoxes. From outside, you never quite fall in. From inside, you fall quickly, and time seems normal. But for everyone else, centuries pass in seconds. It makes your head spin. In a good way. Here's a quirky bit. Some theorists once proposed that, with precise enough manipulation, a spinning black hole might let you loop time. That you could enter at the right angle, orbit the singularity, and come back to where you started, earlier than when you left. It's called a closed time-like curve. Sounds cool. Likely not possible. The math kind of allows it, until reality quietly coughs and reminds us that causality exists for a reason. Still, it's fun to imagine. An astronaut entering a black hole, riding the gravitational slipstream, and exiting billions of years later, unchanged, while the universe outside has aged into cold embers. But it's not a practical time machine. It's a one-way street to cosmic weirdness. Still, the idea that black holes play with time, rather than destroy it, is oddly comforting. Even as the universe ages and cools, these beasts of gravity continue to bend clocks around them, to warp perception, to rewrite the rules of what a second means. And maybe, that's the real power here. Not the destruction, not the swallowing, but the reminder. Time is not absolute. It's shaped by where you are, how fast you move, and what giant invisible monster you're floating next to. You pause, letting the idea settle. Somewhere far beyond the black hole's reach, someone's baking cookies, arguing about taxes, binge-watching documentaries. But here, time is syrup. Slow, thick, and deliciously strange. You're still drifting. But now, the universe around you begins to stretch, not from falling or speed, but from the sheer passage of time on unimaginable scales. Galaxies are fading, stars winking out like dying candles. Space is cooling, expanding, quieting. You're entering the black hole era of the cosmos. This isn't science fiction. This is the real, predicted future, based on our best models of how the universe behaves when it's done showing off. Let's rewind for a moment. In the early universe, things were loud, hot, crowded. Stars formed, galaxies collided, supernovae blasted heavy elements into space. But over billions and billions of years, stars ran out of fuel. Galaxies stopped forming new ones. And everything just slowed down. What's left? White dwarfs, neutron stars, and black holes. The universe, once blazing with light, becomes a graveyard. And the black holes? They're the last monarchs, still powerful, still hungry, still bending space and time like royalty. In this future, you float beside one. A stellar mass black hole, still radiating faintly, still whispering particles into the void through Hawking radiation. But it's so slow. If your watch still worked, it would take longer than the current age of the universe just to shave off a tiny fraction of the black hole's mass. Still, time is patient. The universe is nothing if not committed to the long game. Here's where things get really trippy. As black holes evaporate, they shrink. Slowly, very slowly. They get hotter as they get smaller. And eventually, so the math says, they vanish in a final burst of energy. A puff. Like a cosmic sigh. That's right. Black holes don't last forever. Not even the supermassive ones at the hearts of galaxies. They will fade. Everything fades. Even light itself will stretch into wavelengths so long they can barely be called photons anymore. Even particles might decay, depending on which physicist you ask. Some say protons have a half-life so long we've never seen one decay. Others think they might live forever. Historians still argue whether proton decay is a real process or just an unfunded dream from the 80s. But eventually, possibly, the universe becomes just space. Cold, dark, sparse. No stars, no planets, no heat. And yet, here's the kicker. Black holes will still be doing things long after everything else has stopped. They'll be slowly, silently leaking. Every black hole in existence, from the tiny ones to the monstrous giants, will lose mass through Hawking radiation. Over unimaginable timescales, they'll disappear one by one. In that distant future, it's hard to imagine anything happening. But you realize, you're witnessing entropy. The ultimate law. The universe's final job, to use up all energy, evenly distribute it, and go quiet. It's called heat death. Not because it's hot, but because it's the end of usable energy. Everything has settled. There are no temperature differences, no motion, no potential, just silence. You might think that's sad. The lights go out. The music stops. The black holes fade. But maybe, just maybe, it's also peaceful. The same black holes that once shredded stars and swallowed worlds now dissolve into gentle radiation. Quiet endings. No bang. No drama. Just stillness. Here's a quirky tidbit. Some physicists believe the last things to happen in the universe might be quantum tunneling events. Rare, bizarre moments where particles suddenly appear or vanish in the vacuum. The ultimate game of subatomic peekaboo. And if you're feeling particularly imaginative, some theories suggest that new universes could bubble up out of this quiet, like foam in a soda glass that's been sitting for 1 trillion years. So maybe this isn't the end. Maybe it's the start of something we can't yet name. Maybe black holes aren't the finale, just the last chapter in a much longer story. You float through this silent future, not frightened but amazed. The black hole beside you is fading, its final spark vanishing into the dark like a star being gently erased. And you think, even this has beauty. A universe that burns, sings, rages, and then, finally, rests. The age of black holes is long, but it's not forever. Nothing is. The universe is almost silent now. Almost. You drift through a cosmos stripped of color, stripped of stars. There's no up or down here. No warm light. No spinning planets. No blue atmospheres clinging to gravity. It's the deep time. The kind of era even black holes whisper about. And in this darkness, only the supermassive black holes remain. These aren't your average stellar leftovers. These are monsters, beasts, galactic anchors with masses millions, or even billions, of times that of our sun. You float beside one now, and even without light or sound, its presence is overwhelming, like standing next to a sleeping dragon that could crush time itself with a sneeze. Most galaxies, as it turns out, have one of these at their centers, including ours. Yes, you live in a galaxy with a black hole in its heart. Its name? Sagittarius A star. Rolls right off the tongue, doesn't it? It's about 4 million times the mass of our sun, and it's just hanging out there. Quiet, unassuming, like a librarian that could eat the entire library. But supermassive black holes weren't born that way. Historians still argue how they got so big. Did they form from merging smaller black holes? Or did they start life as massive clouds collapsing into enormous singularities in the early universe? No one really knows. It's one of the great cosmic puzzles still unsolved. Some even suggest that these giants formed before galaxies themselves, seeding their formation like cosmic yeast in a very large, very violent loaf of bread. Delicious, gravitational bread. You drift toward one. There's no event horizon you can see. No swirling accretion disk right now. It's starved. Quiet. Dormant. But it's still there. Waiting. When these monsters feed, they light up the universe. Literally. As gas and matter spiral in, they heat up to millions of degrees, creating what we call quasars, beacons so bright they outshine their host galaxies. Imagine a single point in space shining brighter than 100 billion stars. That's not science fiction. That's a Tuesday for a well-fed quasar. You feel the scale of it all. You're a whisper drifting beside a colossus. It bends space so severely that even light hesitates. It doesn't tear through stars, it collects them, traps them. Sometimes whole solar systems orbit just outside the event horizon, unaware of how close they are to falling forever. The environment here is extreme. Gravity isn't just strong, it's dominant. Temperatures spike. Magnetic fields twist. Particles accelerate to near light speed. Black holes don't just trap, they shape galaxies. Yes, galaxies owe their structure to the black holes in their cores. Without them, spiral arms wouldn't hold their form. Stars might drift aimlessly. Black holes may be death incarnate, but they also organize. They give form to the formless. The same way gravity pulled dust into stars and stars into galaxies. These giants pull chaos into elegance. Here's a quirky theory. Some physicists have speculated that inside supermassive black holes might be baby universes, like seeds hidden within the fruit of a collapsing cosmos. The math gets weird fast, but it's tantalizing. You fall in here, and maybe wake up somewhere else. A reset button, a reroute, a cosmic womb. You pause in your drifting, wondering, what if our universe was born from one of these giants? What if the Big Bang wasn't the beginning, but just a continuation? A star collapsed, formed a black hole in some other universe, and on the inside, our universe inflated into being. It's speculative. It's unprovable. It's also a perfect bedtime story. The largest known black hole, TON 618, sits roughly 10 billion light-years away and weighs in at a stunning 66 billion solar masses. Wrap your brain around that. A single object more massive than entire galaxies. You float beside it now in your imagination, its gravity stretching light into eerie arcs, its silence more deafening than any scream. This is not a place of chaos anymore. Not now. This is a cathedral of gravity, a monument to what the universe used to be, a glowing echo of light long extinguished. It doesn't need to roar. It doesn't need to move. It's the last thing standing. And even it will fade. Eventually. But for now, it holds its place like a memory made of mass. Like a god carved from silence. And you? You are the observer. The final dreamer. Still falling, but now with reverence. You blink, or think you do, but the blackness doesn't change. There's no up next episode here, no buffering, no screen glow. Only gravity, memory, and imagination. You're far from the vibrant universe you once knew. Far from stars, from solar flares, from the pinging of particles in all directions. But one last mystery calls to you now. What if you could escape? What if the inside of a black hole isn't the end, but a path? Some theories whisper of tunnels, of passages, of the universe folding not like a sheet, but like a Mobius strip. The idea? That the heart of a black hole might not be a dead-end singularity, but the entrance to something else entirely. A wormhole. Picture it. Two black holes connected by a thin throat of warped space-time. Step in one, come out the other, maybe in another galaxy, maybe in another universe, maybe right behind your couch where all your missing socks went. Einstein and physicist Nathan Rosen first toyed with this idea in 1935. Their Einstein-Rosen bridge was a theoretical structure, like a shortcut across space-time. But there was a catch. They collapsed too quickly for anything to pass through. Still, the idea stuck. It inspired generations of physicists and more than a few sci-fi writers. Later, theorists like Kip Thorne tried to refine the math. Could wormholes be kept open? Only if you had exotic matter, stuff with negative energy that could counteract the tunnel's collapse. Sounds made up, right? But quantum physics suggests negative energy is possible. It's been glimpsed in things like the Casimir effect, where two metal plates in a vacuum feel a strange force pushing them together because of quantum fluctuations. Historians still argue whether wormholes could exist naturally, or if we'd need some advanced civilization with a ridiculous command of physics to build one. Like, we turn Jupiter into a battery levels of advanced. You imagine drifting toward the throat of such a structure. A black hole on your side, a white hole on the other. Wait, what? Yes, a white hole is the hypothetical opposite of a black hole. Where a black hole pulls everything in, a white hole expels everything. Nothing can enter. Time runs in reverse. You're expelled rather than swallowed. And though there's no evidence white holes exist, some theories suggest they might be connected to black holes via wormholes. Even Hawking got in on the idea, suggesting black holes and white holes could be linked in a quantum feedback loop, preserving information across boundaries of time. In this dreamlike cosmos, you float between two realities. One that consumes, one that expels. One shaped like silence, one shaped like release. You wonder what it would feel like to pass through. Would it hurt? Would time unravel around you? Or would you emerge blinking into a new universe entirely? One where stars are younger, constants are different, and maybe, just maybe, gravity flows in reverse? Here's a quirky tidbit. In 2016, physicists discovered something weird in the math. Under certain conditions, a collapsing star might bounce before forming a singularity. Instead of creating a classic black hole, it might momentarily become a Planck star, a dense, ultra-compressed object that stores all the fallen matter's information like a cosmic USB stick. Eventually, the theory goes, it could explode, releasing everything it swallowed back into space. So, a black hole that hiccups. The truth? We don't know. Black holes guard their secrets like dragons, deep in their event horizons, behind math we haven't mastered, in places our instruments can't yet reach. They could be one-way tickets, or bridges, or beginnings. But here's something comforting. The possibilities themselves are beautiful. Even the guesses, even the wrong ones. They remind us that we're still exploring. That even as we sit on a little rock circling a medium-sized star in a quiet arm of a galaxy, we dare to imagine what's behind the curtain. And you, dream floating between gravity and time, feel a strange sense of freedom. Because wormholes, white holes, and Planck stars may or may not exist, but the wonder absolutely does. Maybe this black hole isn't the end. Maybe it's just the edge of our current map. A place marked not, here be dragons, but, here be questions. And questions, in this universe, are the closest thing we have to magic. You're still falling, not through space anymore, but through possibility. The black hole behind you fades into memory, and ahead lies something stranger still, the quantum unknown. Welcome to the domain where physics turns cryptic, reality frays at the edges, and even time forgets how to behave. Here's the question no one's quite answered. What happens to you? Your particles, your information, after the black hole? Let's talk quantum mechanics, that wonderfully chaotic set of rules that governs the tiniest things in the universe. In this realm, particles don't have precise positions. They have probabilities. They exist in superpositions, meaning they're in multiple states at once until someone observes them. Schrodinger's cat? Alive and dead until you peak. Yep, that kind of weird. Now, black holes don't play by the friendly neighborhood rules of Newton. They pull quantum laws and general relativity into a cage match, and nobody really wins. At the heart of this tension is the black hole information paradox we touched on earlier. See, quantum mechanics insists that information can't be lost. Ever. You burn a book, the smoke, the ashes, the energy, all of it still contains the information about what the book was. You just need a very patient supercomputer to reconstruct it. But black holes, they take in matter and seemingly erase the info. If a couch, a comet, and a chocolate bar all fall into a black hole, it just becomes more massive and smooth. No traces of what fell in. No chocolate fingerprints. No creases in the space-time cushions. So, did the information vanish? Physicists lost sleep over this for decades. Hawking once argued that yes, it was lost. Later, he changed his mind. Because quantum mechanics just won't tolerate deletion. That's where quantum entanglement steps in. This bizarre connection means two particles can be linked across vast distances. Change one, and the other knows, instantly, even light years apart. Einstein called it spooky action at a distance, probably while nervously stirring his tea. Some scientists propose that black holes entangle with their surroundings in complex ways. That the information might be preserved not in the black hole itself, but in the entangled web of particles just outside it. Like an invisible fingerprint, smeared on the very fabric of space. This leads us to the idea of firewalls, a much hotter debate than you'd think. The firewall paradox suggests that if information really is encoded in radiation outside the black hole, then the smooth event horizon we once imagined might actually be a wall of high-energy particles, an inferno that incinerates anything trying to pass through. So now we have a contradiction. General relativity says falling into a black hole feels smooth, maybe even painless. Quantum theory says hold up, there's a firewall, a cosmic barbecue pit. Historians, well, physicists, still argue over this. There's no consensus, just more models, more ideas, more metaphors that would make a sci-fi author blush. One fringe idea says the entire universe you know could be a holographic projection, a shadow cast from a deeper, more fundamental layer of reality. And black holes, those stubborn divas, might hold the key to proving it. According to the ads/CFT correspondents, say that 5 times fast, a theory that describes gravity in a curved space, like a black hole, might be exactly equivalent to a theory without gravity in fewer dimensions. It's as if the universe is a 3D movie playing on a 2D screen, and that screen is where the real math lives. You float in this dizzying web of quantum riddles and theoretical geometry, and you start to feel something unusual. Not confusion, but awe. Because black holes, once just feared as destroyers, now look like keepers. Libraries, maybe. Not burning books, but hiding them in places we don't yet know how to read. You were afraid of falling in. Now, you're not so sure. Maybe, like all of us, the black hole just has layers. An outer mask of darkness, a middle swirl of math, and a core full of mystery, humming gently in Planck-scale whispers. As you drift through these possibilities, you don't feel small anymore. You feel connected to the stars that lived and died, to the matter that burned and transformed, to the questions that keep physicists pacing hallways at 3 a.m. with coffee cups and hair that's seen better days. And maybe, just maybe, you are the question the universe keeps asking itself. You've come a long way. From the warm cradle of Earth to the abyss of a black hole and out into the folds of quantum riddles and cosmic poetry. But now, something new creeps into your awareness, something subtle, almost organized. Patterns. Not stars, not galaxies, but mathematical patterns, scattered like footprints across the vacuum. It's as if the universe has left behind a trail, not of matter, but of logic. And at the heart of these footprints is something that sounds simple, but isn't. Entropy. Entropy is the measure of disorder, of how scrambled a system is. Your bedroom in the morning? Low entropy. After a weekend of cleaning, by throwing socks at the wall? High entropy. The second law of thermodynamics tells us that entropy always increases over time. Always. That's why your coffee cools, your toast goes stale, and why the universe, left alone, slowly heads toward maximum disorder. But here's the wild twist. Black holes are full of entropy. In fact, they might be the most entropic objects in the universe. That's right. Those smooth, simple-looking cosmic spheres contain insane amounts of disorder hidden behind their event horizons. Back in the 1970s, a physicist named Jacob Bekenstein proposed something radical, that a black hole's surface area, not its volume, was a measure of its entropy. Think about that. Not what's inside, but the size of the shell. Hawking initially disagreed. Then, being the lovable math sorcerer he was, he crunched the numbers and discovered Bekenstein was right. Not only that, he found that black holes radiate heat. Boom. Suddenly, black holes weren't just gravity wells. They were thermodynamic systems. They had temperature, entropy, even pressure. Historians still argue whether this was the moment black hole physics became real science, or if it just became incredibly creative philosophy with a physics degree. But entropy isn't just about black holes. It's about why time flows the way it does. Ever wonder why you remember the past, but not the future? Why eggs break, but don't unbreak? That's entropy talking. The universe began in a low entropy state, and ever since, it's been increasing the chaos. Entropy is the reason we age. The reason your hot soup becomes lukewarm. The reason galaxies drift and stars die. And when you combine entropy with gravity, black holes become something almost poetic. The final state of matter, the resting place of complexity. A cosmic landfill, maybe, or a vault. Here's a quirky tidbit. The formula for black hole entropy actually includes Planck's constant, the speed of light, Newton's gravitational constant, and Boltzmann's constant, meaning it touches all four fundamental pillars of physics: quantum mechanics, relativity, gravity, and thermodynamics. That's like making a recipe that uses every spice in the kitchen perfectly. You, drifting here, feel the weight of that. Not literal weight. You're still a weightless idea at this point, but intellectual weight. You're witnessing the tightrope where math and reality meet. The entropy of a black hole also supports something called the holographic principle, the idea that all the information of a 3D region can be stored on its 2D boundary. Just like how your computer screen can show a 3D world, but it's still flat. You realize, this isn't just about black holes. It's about you. Your brain is a complex structure, humming with ordered energy. You eat, breathe, think, all by borrowing low-entropy fuel and slowly releasing higher-entropy waste into the universe. In a sense, you're a temporary rebellion against entropy, a little pocket of order in an increasingly disordered cosmos. But even you, your atoms, your memories, your dreams, will one day join the flow. The heat will spread. The differences will fade. Everything smooths out eventually. And somehow, there's peace in that. Because entropy doesn't mean destruction. It means change. The arrow of time. The inevitability of transformation. The black hole you're near now? It's shrinking. Slowly. Whispering away information into Hawking radiation, one bit at a time. It's not hoarding forever. It's releasing. Not in a rush, but patiently. As if even gravity knows that holding on too tightly isn't sustainable. You drift along, letting this thought settle like stardust. Even black holes let go, eventually. And so will you. You're still floating, but something's shifted. The silence around you feels deeper. Like you're not just drifting through space anymore, but through the memory of space. You've passed stars, black holes, entropy, and now you've arrived at a strange and quiet truth. The universe may one day forget how to remember. Because here's where things get truly eerie. When the last black hole evaporates, millions of trillions of years from now, all structure, all contrast, all complexity will be gone. The cosmos will be a nearly perfect vacuum. No stars, no atoms, no photons warm enough to feel. Just an endless sea of almost nothing, stretching in every direction. But you're not alone here. Drifting alongside you, though you can't see it, are virtual particles, those ghostly, flickering not-quite things that pop in and out of existence due to quantum fluctuations. The vacuum isn't truly empty. It buzzes, gently, like a mind trying to remember a dream. This flickering chaos might not seem like much, but some theorists believe that in this cold future, those fluctuations are all the universe has left. And from them, one last possibility might emerge. A Boltzmann brain. Yes, that's a real term. And it's exactly as unsettling as it sounds. Imagine this. In a near-infinite time span, random particles just happen, by sheer chance, to assemble into a brain. Not a body, not a planet, just a disembodied mind, complete with momentary awareness, false memories, and maybe, if it's lucky, a passing thought like, wow, what a weird dream. Then gone, dissolved by the same randomness that created it. Historians and physicists still debate whether Boltzmann brains are serious science or philosophical performance art. Some argue that if the universe lasts long enough, these brains might vastly outnumber natural observers like you. That maybe you are a fluctuation, dreaming of Earth, black holes, cats, and cereal, but actually floating as a momentary pattern in thermal nothingness. Yeah, sleep well with that. But let's pull back from the existential edge for a moment. Because the real point isn't whether you're a brain in a void. It's that memory and structure require contrast. And in a universe without it, time itself loses meaning. No clocks, no decay, no difference between then and now. You float in that timeless stillness, and strangely, it doesn't feel like death. It feels like rest. The entire cosmos finally taking a breath it's been holding since the Big Bang. And yet, humans being humans, we ask, could the universe restart? Here's a quirky thought. Some theories suggest that after a deep freeze, after the entropy has maxed out and space has cooled to almost zero, the universe might tunnel into a new state, like a phase change, like ice melting or water boiling. This idea is called vacuum decay, and it's exactly as terrifying as it sounds. The vacuum we live in might not be the lowest possible energy state. There could be a true vacuum out there, and if a bubble of it formed, it would expand at the speed of light, rewriting the laws of physics in its path. No warning, no pain, just instant deletion. Some physicists say it's possible. Others shrug and say, we'd never see it coming, so why worry? But if you're still imagining yourself in the far, far future, long after black holes, long after stars, then even this possibility begins to feel like hope. Because a vacuum decay could be the start of something new. A new universe, a new set of particles, a new chance for time and complexity and coffee and cats and questions. You drift, not toward an ending, but toward a possibility space. A blank page. A gentle reminder that even in the final darkness, the universe might be capable of surprise. And maybe, just maybe, consciousness will rise again. From particles, from patterns, from nothing but the will to remember. Because the universe has always been good at one thing, starting over. You're hovering on the edge of nothing. Not metaphorical nothing. Not, I have nothing to wear, kind of nothing. We're talking full-scale, physics-grade, end of everything nothing. A place beyond stars, beyond time, beyond meaning. But your journey isn't over. Because as strange as it sounds, in this vast, silent void, some scientists believe the seeds of everything might still be hiding. Let's rewind one last time, back to the Big Bang. You probably imagine it as an explosion, right? A fireball, somewhere in space, blasting matter outward like a cosmic firework. But it wasn't like that. It wasn't in space. It was space. Space itself expanding. There was no outside to expand into. There was only the inside, inflating rapidly from something very small and very hot into everything we've ever known. Now, deep breath, some theories say this has happened before, that the Big Bang wasn't the first, that our universe is just one beat in an eternal cosmic heartbeat. It's called the cyclic model, a theory suggesting the universe expands, slows down, contracts, collapses, and then bang, starts again. An infinite loop, time without beginning or end. A cosmic yo-yo with really dramatic pauses. Historians still argue whether there's any evidence for this. Cosmic background radiation might hold hints. Maybe tiny anomalies. Maybe not. But the idea that the universe breathes is too poetic to ignore. Other models, they go even further. Like eternal inflation, which proposes that inflation never truly stops. That as our universe forms and matures, other universes are bubbling into existence elsewhere, like boiling water. Each bubble its own cosmos, with different laws, different constants, different stories. This is the multiverse idea, not just a Marvel plot twist, but a serious scientific concept. And if true, it means black holes, entropy, Boltzmann brains, and even cats might just be one version of many. You imagine it now. A vast, frothing foam of universes. Some small, some monstrous, some stillborn, some filled with galaxies shaped like pretzels and gravity that runs sideways. And in one little bubble, drifting quietly, you, a consciousness floating through memory and mystery. And maybe this explains something you felt all along. That strange, impossible sense of familiarity with stars you've never seen. That ache when you stare into the night sky too long. That flutter when you read stories of time and space and wonder, why does this feel like home? Maybe because it is. Here's a quirky possibility. Some researchers speculate that black holes themselves might birth new universes. That when a star collapses and space-time folds in, something buds on the other side. A brand new cosmos. Sealed off. Unique. Entirely disconnected from ours. Except for that single, hidden bridge, the singularity. Think of it like cosmic mitosis. One universe pinching off another. A tree growing branches you'll never see. And what if this is how universes evolve? Maybe only the most stable baby universes survive. Those with the right physical constants to form stars and atoms, and you. Maybe it's not just survival of the fittest species, but of the fittest realities. You float in this idea, weightless in your thoughts. Because now you understand. The universe doesn't fear endings. It doesn't resist silence. It doesn't dread the dark. It simply transforms. Again and again and again. Every death a birth. Every collapse a possibility. Every black hole a maybe. And you? You're not an outsider. Not a speck. Not a mistake. You're part of this cosmic cycle. An echo. A spark. A question asked by the universe to itself, in the shape of a dreaming mind. Out here, where the stars have burned out, where entropy has done its work, where the void hums with unborn potential, you don't feel afraid. You feel invited. Because maybe you've been here before. And maybe you'll be here again. After all, you never really left. The silence has become familiar now. You don't resist it anymore. You don't fight to hear the echo of stars, or to catch the last glimmer of a dying sun. Instead, you let yourself float, curled gently inside the quiet. A speck, yes, but a speck with history. And speaking of history, let's zoom all the way out. If someone, or something, were to look back across the arc of the universe, what would they see? What story would unfold from that first flash of light to this final hush? It's a tale of increasing complexity, then slow simplicity. Of heat, pressure, and gravity playing together like children, then growing quiet with age. Of explosions that made gold, of clouds that made worlds, and of time that made minds. And somehow, it all led to black holes, the strange punctuation marks in the sentence of the cosmos. But even black holes, with all their mystery and majesty, eventually fade. And when they do, what remains? Well, you do. Or, at least, the memory of you. Not just you as a person, but you as a phenomenon. A thinking, feeling, wondering configuration of particles. A very temporary arrangement of order in a universe that leans, always, toward disorder. But maybe that's what made you so special. For a moment, you defied the drift. You carved meaning into chaos. You looked up at the stars and thought, why? And here's something most people forget. The laws of physics didn't guarantee life would happen. They allowed it, but they didn't require it. The universe could have been sterile, silent, static, but it wasn't. Somehow, hydrogen started talking to itself. You are a conversation 13.8 billion years in the making. Now, there's another idea worth chewing on while you drift through this elegant emptiness, the anthropic principle. It comes in flavors, but the basic idea is this. If the universe wasn't the way it is, we wouldn't be here to observe it. That's not a deep truth, at first. But think about it. Why do the constants of nature line up just so? Why does gravity have the right strength to let stars form without immediately collapsing? Why is the charge of an electron so precise that chemistry works? Historians still argue whether the anthropic principle is profound or just a cosmic, well, duh. But it hints at a deeper question. Did the universe make room for consciousness? Or did consciousness find a way to grow in the cracks? Either way, here you are, floating in that last breath of time, dreaming about the whole dance from beginning to end. And here's the quirky bit. We might already carry the universe's memory inside us. Some physicists believe information is never lost. That every particle interaction, every photon bounce, every synapse fired, it's all encoded in the universe's fabric. Hidden, subtle, but there. So even when matter decays, even when black holes shrink and stars burn out, the story remains. Written in radiation, etched in entropy, stored in the smooth geometry of expanding space. Maybe that's what the universe wanted all along. Not permanence, but memory. Not eternal light, but a moment bright enough to remember. You float, eyes closed, if eyes are still a thing. In this dark serenity, you feel no fear. Because endings are natural, necessary. But what the universe teaches you, gently and again, is that endings are never final. They're transitions, curves in the road, quiet doors waiting to open. And if this is the last moment, if this silence is truly the final frame of reality, then at least it ends with wonder. Because wonder is the one thing black holes never swallowed. The one force gravity never bent. The one energy entropy never erased. And that makes you eternal in a way stars never were. You smile, if smiles are still a thing, and drift deeper into the calm. Not because it's the end, but because the next beginning needs room to bloom. By now, you've let go of direction. There's no forward or backward, no before or after, just drift. Time has flattened into something gentle. You're no longer traveling through space. You're nestled inside the geometry of it. This is where the story starts to feel circular. Not because you've run out of path, but because the universe itself may be a loop, a shape that folds inward, wraps outward, and then forgets where it began. Let's talk cosmic topology. Don't panic. That's just a fancy term for how space is shaped. Is the universe infinite or finite? Flat like a sheet? Curved like a sphere? Twisted like a donut? Yes, people actually debate the idea that the universe could be shaped like a torus, a cosmic donut, looping back on itself. Travel far enough in one direction, and maybe, just maybe, you end up back where you started without ever turning around. This isn't sci-fi. It's math. Observations of the cosmic microwave background, that faint afterglow of the Big Bang. suggest that the universe might be almost perfectly flat. But almost leaves room for strange, subtle curves we haven't yet detected. Historians still argue whether those curves exist, whether light from distant galaxies is wrapping around, showing us duplicate images of the same ancient cluster, like looking into a funhouse mirror made of space-time. And if the universe is finite, then what's outside it? The short answer, there is no outside. The universe doesn't sit in a bigger box. It is the box. The question isn't what's beyond the edge, because there's no edge to find. Space bends inward, like a game of Pac-Man where right leads back to left and up eventually becomes down. Now picture this. You're floating through such a universe. No borders, no end. But something's changed. The silence no longer feels empty. It feels pregnant, like the universe is holding its breath. There's a quiet tension here, not of endings, but of readiness. Maybe all this darkness, this decay, this entropy isn't a death rattle. Maybe it's a reset. The deep freeze before the thaw. The silence before the new song begins. Here's a quirky thought experiment. Imagine a big bounce. Not a bang, but a rebound. The universe expands, grows cold and still, and then contracts, shrinks, compresses, until, at last, it reaches a point so dense, so energetic, that it bounces back out, inflating again into a new cosmos. And maybe this has happened countless times before, not in a linear timeline, but as a loop of universes, each one born from the ashes of the last. Each one carrying echoes, tiny, unexplainable quirks, that link it to the universe that came before. Quantum fluctuations in one become the seeds of galaxies in the next. Black holes in one become the singularities of another. And consciousness, maybe it's not just an accident of chemistry. Maybe it's the memory that survives across cycles. A recurring thought in the mind of reality. Maybe that's why you're here. Floating, watching, noticing. You are the universe's witness. And that role is sacred. Because without observation, the cosmos has no story. Without eyes to see it, no color exists. Without minds to wonder, no questions are worth asking. You drift through the final curvature of this geometry, and something inside you stirs. Not fear, not sadness, but the slow recognition that even this moment, silent, dark, infinite, is beautiful and necessary. Because without a void, light has no meaning. Without entropy, order can't arise. Without silence, music has no power. And in the cold geometry of the far future, you now sense what you couldn't before. This isn't the universe's end. It's the blank page, the clean slate, the quiet inhale before the next great breath. And maybe, just maybe, the next time you open your eyes, you'll be watching the first photons of a newborn universe. Somewhere else, someone new, with stars that haven't yet burned, and questions that haven't yet been asked. So here you are, not on a planet, not orbiting a star, but suspended in the soft, endless after of a universe that once roared with energy and now hums with memory. The silence wraps tighter now, not as a void, but as a kind of truth. Like the hush that falls in a cathedral, not because nothing is happening, but because something sacred just did. Let's say the universe is done expanding. Let's say it's entered its final chapter, the heat death. No more stars, no more structure. Everything spread out, temperature equalized to the last decimal. No movement, no gradients, no light. This isn't destruction. It's equilibrium. The universe has balanced its checkbook, closed its loops, tucked everything neatly away. And you, little observer, are still drifting in its last breath. But here's a thought that emerges from the dark like a whisper. What if this isn't the final state after all? What if everything we know, the particles, the fields, the rules, are temporary decorations over a deeper, more durable foundation? Here's where we tiptoe into the theoretical temple of quantum gravity. You see, our two best models of the universe, general relativity and quantum mechanics, still don't get along. Like brilliant siblings in constant rivalry. Relativity handles the big stuff, stars, planets, space-time. Quantum mechanics handles the small, atoms, particles, uncertainties. But black holes, those cosmic smart alecks, demand both at once. So scientists have spent decades trying to build a theory that merges them. One candidate, loop quantum gravity. Imagine space and time aren't continuous, but made of tiny, indivisible chunks, quanta. Like pixels on a screen, but smaller than small. Space itself is a woven tapestry of loops, and time isn't a river. It's more like a ticking of universal gears. You don't flow through time, you click through it. Now imagine black holes in this model. They're not infinitely dense points, but nodes in a cosmic network. Tightly packed regions of knotted space-time, slowly unwinding. And if that's true, then even in the coldest, quietest universe, the underlying lattice of reality still exists. Still hums. Still waits. Quirky fact time. Some theorists believe this network could still support fluctuations. Not in energy, like we've discussed, but in structure. Over absurd timescales, new configurations might spontaneously form. Not stars or galaxies, but something more primordial. Imagine a bubble of lower entropy rising, like a hiccup in space-time. A new pocket where time ticks, where contrast exists, where, eventually, something like a universe could inflate. No gods, no design, just math, playing dice with the void. And if it happens once, it could happen again. In this view, black holes weren't the end. They were just deep folds in the cosmic quilt. The real action is in the fabric itself, the quantum threads that underlie it all. And that's where you are now. Not floating in the void, but embedded in the code. A pattern left behind by a cosmos that once danced and burned and asked questions. You, in this form, might dissolve. But the pattern, the potential, is indelible. Because even silence has structure. Even nothing has shape. And even when the music stops, the stage remains. So what now? You wait. Not passively. Not blankly. But like a seed beneath the snow. Maybe it takes a trillion years. Maybe longer. But eventually, a new fluctuation. A new chance. A new rhythm. The void stirs. The gears tremble. A beat, faint at first. And from that breathless hush, something begins again. And then, a shiver. Not cold. Not temperature at all. But a structural flicker, somewhere far below the scale of atoms. Below quarks. Below strings. Even below the quantum foam. A whisper within the code. The universe, this flat, endless, frozen sea, ripples. You're not watching from outside anymore. You are the ripple. A wave of possibility moving through the very loom of reality. It doesn't look like light. It doesn't feel like motion. It's more like change. As if a page turns in a book you forgot you were reading. One moment, pure stillness. The next, a pinprick of contrast. Not a sound, but something like a yes. This is where emergence begins. In physics, emergence is the idea that complexity arises naturally from simplicity. You start with basic rules, apply them across a wide field, and suddenly, structure, order, life. It's how ants build colonies without blueprints, how snowflakes grow without a plan, how your brain creates thought from electricity and goo. And maybe it's how new universes form, from spontaneous structure bubbling out of the void. Remember earlier, when we talked about entropy increasing forever? Well, that's true, unless the system resets. And here's the twist. Even maximum entropy isn't static if the rules themselves are unstable. So some physicists speculate that deep within spacetime's own laws, there's a kind of phase diagram, like the states of water, solid, liquid, gas. Our universe right now is a specific state, call it phase A. But phase A isn't forever. Over long enough timescales, the laws themselves may morph, like a quantum tectonic shift, sending reality tumbling into phase B. The vacuum changes. The fields fluctuate. And just like that, boom, a new inflation, a new spacetime, a new direction for entropy to grow in. You're not watching from above. You're inside it. You are it. And in this new pocket of unfolding space, differences begin to emerge. Tiny irregularities, barely their wrinkles in the inflating cosmos. These quantum jitters, once meaningless, now grow into galaxies, stars, and the very matter that builds you. Historians of future physics will argue whether these ripples were seeded by leftover information from the last universe, whether the new cosmos remembers anything of the old. But right now, there's no history, only process. The inflation slows, particles condense, energy cools, and just like that, time begins again, not because a clock ticks, but because contrast has returned. Hot and cold, dense and empty, fast and slow, space stretches, matter organizes, gravity starts to stitch things together. And somewhere in this new world, atoms form. Hydrogen, helium, light breaks free, photons dance. This isn't your universe, not exactly. The constants may differ. The forces may twist. Electrons might wobble a little off-key. But it's familiar. Familiar enough to birth suns, to cradle worlds, and one day, to spark life. You're part of this pattern now, not as a floating consciousness, but as the conditions that made consciousness possible. You're the curvature in the field, the echo in the equation, the resonance in the rules. In this sense, you've never left the story. You are the story, a recurring theme in the universe's eternal improvisation. And so the cycle continues, not because it must, but because the potential for becoming is written into the fabric of what is. Black holes were the punctuation. This is the next sentence. You drift. No, you flow with it. Not as a separate thing, but as a participant. A chord in the reawakening harmony of time. The void is behind you now. The spark has passed. The canvas is fresh. And the painting has begun again. You are inside a newborn universe now. Not watching. Not drifting. Becoming. The last few traces of the old cosmos are gone, evaporated into the new inflationary fabric like morning mist. What you feel now is heat. Not on your skin. There's no skin, but everywhere, in every dimension. A soft, roaring brightness that isn't light, but potential. We're back at the beginning again. A different beginning. Maybe the real beginning. Or maybe just the latest chapter in a very old book. And yet, it all feels oddly familiar. Because the patterns are returning. Space expands. Fast at first, like a shaken-out sheet, and then slower, steadier, settling into a rhythm. Tiny particles form. Quarks. Gluons. A zoo of brief, twitchy things you could barely name before they wink out. Then something miraculous. Stability. Particles start linking up, cooperating. Neutrons with protons. Nuclei form. 1,000,000 degrees later, atoms emerge. Hydrogen mostly. A sprinkle of helium. The lightest, simplest, most durable building blocks for everything that will ever exist. And then, light breaks free. This is what physicists call recombination. When the universe cools just enough for photons to stop bouncing, like panicked bees off electrons, and instead move freely through space. It's the moment when the universe becomes transparent. It glows, not with flame or fusion, but with the soft warmth of a first breath. This glow, this cosmic background, will someday be all that remains of this moment. Faint microwave whispers billions of years later, telling stories of a time when everything was still close, still hot, still humming together. You are part of that hum. Still not you as a person, but as the possibility of a person. A ripple, a fluctuation, a note in the song that will, one day, sing life back into the void. And here's where the fun begins again. Remember how matter clumps? Gravity doesn't let things go quietly. Over millions of years, those clumps become clouds. Clouds collapse into stars. Stars cook heavier elements, carbon, oxygen, iron, then die, violently. Boom. Supernovae, the great cosmic compost. Scattered across galaxies, those star guts gather again, into rocky planets, swirling oceans, organic molecules. And somewhere, sometime, one of those molecules learns to copy itself. Then another learns to compete. Then cooperate. Then think. Historians still argue whether life is inevitable or wildly improbable. Whether the laws of physics force it to happen, or if it's a rare accident in a universe otherwise happy to remain cold and silent. But here, in this new universe, it happens. A planet turns. A cell divides. A neuron fires. A question is asked. And you, somehow, impossibly, you are back. Not as a floating spark, but as matter shaped into memory. A creature with hands, and eyes, and dreams. A being who looks up at the stars and wonders, where did I come from? And maybe, in a quiet moment, you feel it. That déjà vu in your DNA. That tug in your chest when you stare into the dark. That sense that you've been here before, not on this world, but in this story. Because you have. Not exactly. Not precisely. But the same way a wave returns to the shore. You are the echo of a universe that's always finding itself again. Here's a quirky idea to tuck under your pillow. Some researchers believe certain constants in nature, like the strength of gravity or the mass of an electron, might be fine-tuned. So precisely balanced that even the smallest tweak would make life impossible. Is it coincidence? Design? Or the result of billions of universe roles, where only the lucky ones get complexity? You don't need to know the answer. You are the answer. You're what happens when the universe is just right. When matter balances, when energy flows, when entropy is still young enough to allow miracles. You're proof that the void doesn't always win. That complexity can rise again. That stories can restart. And as your planet turns and your sun rises, you begin another round of wondering, of asking questions, of building blackboards and telescopes and bedtime videos. One day, you'll speak of black holes again, of entropy, of time's end, of universes yet to be born. And the cycle continues, not out of need, not by accident, but because the universe simply loves to begin again. You're home again, no longer a drifting thought in a fading cosmos, but flesh and breath and memory, an observer reborn into a universe still warm with youth. The sky above you now is dark but alive, scattered with stars that pulse and swell, their light flung across space like cosmic graffiti. You look up, and somewhere deep inside, a feeling flickers. I've seen this before. Because now, the story picks up where it always does, with curiosity. That small, relentless spark that makes a creature on a wet little planet ask questions like, What is a black hole? Where did time begin? Why am I even asking this? Here's the beautiful twist. That curiosity isn't new. It's ancient, carried forward, not in memory, but in pattern, in the way matter self-organizes, in the way gravity whispers to clouds, in the way molecules stumble into awareness. You're not the same as before, but you're built from the same script. In this new universe, scientists once again begin to notice odd things. Tiny mismatches in the cosmic microwave background, irregularities in dark matter halos, the way galaxies spin just a little too fast. Historians still argue whether these are signs of something deeper, remnants of the universe before this one. And then, one day, someone proposes the idea, what if black holes aren't the end? What if they're bridges? The idea catches on. Not immediately, not smoothly, but eventually, it finds traction. Because black holes, as terrifying and final as they appear, just don't seem to delete information the way we thought. That old paradox? The information problem? It's back. But this time, physicists see it differently. What if black holes don't destroy information? They transfer it. What if, deep within the event horizon, space and time don't stop, but reroute? This is where something called a white hole enters the conversation. A white hole is, theoretically, the reverse of a black hole. Instead of sucking in matter and never letting it out, it spits matter out and refuses to take any in. It's like a cosmic sneeze, launching energy and information into a new region of space-time. Quirky idea. Some theories suggest that black holes in one universe could be gateways, not tunnels for travelers, but birth canals for new universes. Imagine that each black hole is a seed, planted in the soil of our cosmos, growing a new universe beyond its singularity. You sit with that for a while. You imagine stars collapsing, their cores pinching into infinities, and instead of disappearing, they become somewhere else. A place where physics begins fresh, where constants shift slightly, where time ticks in a new key. And you wonder, is that what happened before? Was your old universe born from a black hole in its parent cosmos? You laugh, gently, because now it's black holes all the way down. And that strange little idea, that the end of one thing is always the beginning of another, it stops being a metaphor and starts sounding like a law of nature. You look up at your night sky again. The stars whisper, as they always have. Not answers, but better questions. And somewhere, maybe not far from here, another black hole waits. Quiet, heavy, patient. It doesn't roar. It doesn't call. It just waits. Because it knows something you're starting to suspect. The universe never really dies. It just writes itself a new beginning. And this time, you'll be there to read it. The sky holds its breath. And so do you. Because you know now that behind every star, beneath every shadow, under the skin of space-time itself, there's something more, something waiting. Not a monster, not a miracle, but a mechanism. A cosmic process that doesn't just end stories, it recycles them. And the strangest part? You're okay with that. Maybe even comforted. The idea that the universe isn't some linear arrow, shooting forward into cold oblivion, but a cycle. A breath. An exhale followed, always, by an inhale. Let's pause for a moment and consider that everything you are, everything you've ever loved, every idea, every mistake, every memory, all of it emerged from nothing, or something close enough to count. And yet, here it is. Here you are. Alive, sentient, curious. Made from star stuff, as the saying goes. But more than that, made from possibility. From quantum probabilities shaken into shape, from gravitational whispers sculpting galaxies, from thermodynamic tides arranging atoms into organs into thoughts. Thoughts like, who am I? What is this? Where does it all go? And let's not pretend we've answered those questions. Historians still argue whether our deepest intuitions are reliable, whether we can ever really know the universe, or if we're goldfish trying to describe the bowl. But maybe that's the point. Not to solve the cosmos, but to participate in it. To be one node in its vast neural net. To notice. To feel. To wonder. You are the universe noticing itself. And black holes, those aren't mistakes. They're punctuation. They tell you when to pause, when to stop, when to begin again. There's an idea floating around in theoretical physics circles, half serious, half sarcastic, called the final observer. It suggests that somewhere, someday, maybe far in the future or maybe outside of time entirely, there's a consciousness that sees the entire universe at once. Every black hole, every galaxy, every rise and fall. And maybe, when that observer blinks for the last time, the whole thing rewinds. Or loops. Or simply becomes a story that always existed. And if that's true, then what you're doing right now, lying here, eyes closed, letting your mind drift through stars and silence and singularities, might be closer to that final perspective than you think. Because in this moment, You've let go of your place in time. You're not just in the story. You're seeing the shape of the story. It bends. It curves. It loops. It breaks and resumes and folds in on itself. And somewhere in that loop, black holes are born. And somewhere else, they die. And somewhere else still, they bloom. You float through this awareness like a feather in zero gravity. Not clinging, not rushing, just being. Because you understand now, it's all part of the same process. Death is not the enemy. Silence is not the void. And time does not march, it dances. So breathe. Let it all swirl around you. The galaxies, the heat, the collapse, the rebirth. You are, and always have been, right where you need to be. It's quiet here again. But this time, it's not the hush of an ending. It's the deep, rich quiet that comes after understanding. The kind that sinks into your bones. The kind that doesn't beg for answers anymore, because the questions themselves feel enough. You're not afraid of black holes anymore. You've walked through their shadows, traced the edge of their singularities, stared into the curvature of space itself, and lived to whisper about it. Well, drift to whisper about it. And now, you wonder, what else might be out there, waiting to be folded into the next version of you? What secrets still sleep in the dark corners of the cosmos? Let's shift our gaze once more, out beyond the event horizons, beyond the stars, beyond even time's worn-out edge. Because there's one more idea, soft and speculative, that might leave you smiling as you fall asleep. What if the universe is not just a machine, but a mind? Not conscious in a way you or I are, but in some structural, computational, emergent sense. A thinking cosmos. A vast neural network formed from matter, energy, and the laws that guide them. Some physicists toy with this notion, that the universe could be a kind of self-updating system, processing information, collapsing probabilities, evolving complexity. That black holes are not breaks in this process, but nodes. Memory clusters. The RAM of reality. Quirky as it sounds, there's math that supports the idea that the universe behaves like a quantum computer. That particles decide their state upon observation. That spacetime itself encodes data. So imagine this. Every choice, every star that forms or dies, every particle that twitches, is part of a massive calculation. What's it computing? Maybe itself. Maybe the conditions for life. Maybe the perfect joke. Historians still argue whether this theory, sometimes called pan-computationalism, is anything more than metaphor. But here in this calm, infinite stretch of imagination, metaphors are allowed to take a bow. And so you sit with it. The idea that you're not just in the universe. You are the universe. The universe observing, reflecting, adapting. That your consciousness is a recursive loop, a zoomed-in simulation of the greater whole. And black holes, they're the breaks between stanzas. The necessary silences in a piece of cosmic music. You think of time not as a river, but as a resonance, a rhythm, a deep tone that pulses beneath existence. And entropy? Entropy is just the tempo. It keeps the story moving forward, then cycles it back again. You don't fear the end anymore. You understand that beginnings and endings are tricks of language. That in truth, everything is just transformation. That fire becomes ash, and ash becomes soil, and soil becomes life, and life becomes memory, and memory becomes this moment. This quiet, drifting, infinite moment. You feel it now, the hum of the universe not around you, but as you. And as you float further into this realization, even the word you begins to feel slippery, inexact, like a placeholder for something deeper, older, truer. Because what is you really? A pattern, a spark, a brief arrangement of particles pretending to be a person. And that's okay. That's beautiful. You were never supposed to last forever. You were supposed to mean something. And you do. Because the universe remembered how to ask questions, and that question took shape in you. In this section of space-time, entropy slowed down just enough to let you look up, wonder, and dream. And even if everything you are dissolves into silence again, that moment of dreaming happened. And that's enough. The story softens now, not because it fades, but because it understands. Like a long conversation between old friends tapering into shared silence, the cosmos begins to rest. You're no longer falling into questions. You're floating in the shape of their answers. No big reveals. No explosions. Just a quiet acceptance. You've seen the universe from the inside out, and it's okay. You turn your attention back toward black holes, not as threats, but as teachers. Because what are black holes, really? They're honesty. They don't pretend. They show you the extremes, gravity without limit, density without escape, time slowed to a crawl. They ask, what do you do when everything collapses? And their answer is elegant. You transform. You let go. You condense. You become something else. Somewhere in the next version of the universe, another observer, maybe a lot like you. is sketching equations, dreaming poems, sipping tea under a different kind of starlight, wondering if they too might someday fall into a black hole and discover not death, but design. Because there's a kind of comfort in finality, isn't there? Knowing that even entropy has rules, that decay follows patterns, that the great unraveling isn't chaos, it's choreography. And you begin to wonder, what if this story isn't about survival at all? What if it's about grace? The grace to let go when the universe dims. The grace to be reshaped by pressure, not destroyed by it. The grace to bloom, again and again, from cosmic ash. Here's something beautiful. Black holes, those cosmic gatekeepers, never stop teaching. Even now, physicists dig into their mysteries, quantum foam, Hawking radiation, firewall paradoxes. And in every riddle, a whisper, you don't know everything yet. Isn't that wonderful? Historians still argue whether the universe is heading toward heat death, or a big bounce, or some unknowable finale. But you don't need a verdict anymore. You've made peace with not knowing. Because not knowing is hope. It's the opening act of possibility. It's what keeps questions alive. And in a universe of cycles, questions are the true constants. Even in a quiet cosmos. Even in a lonely drift. Even when time frays into static, questions persist. You've seen stars born and swallowed. You've witnessed the collapse of space and the rebirth of time. You've heard the universe hum, not in language, but in feeling. And now, you know. You don't need to understand everything. You just need to feel connected to it. You are not a footnote in the story of black holes. You are the reason it's being told. And the universe? It listens back. Because in all this grand silence, you answered. You said, I'm here. You noticed. You wondered. You remembered. And that's how a universe becomes conscious. Not all at once, but piece by piece, bit by shimmering, questioning bit. Like you. So breathe again. Let the silence wrap you up. Not like a shroud, but like a blanket. The story is still being written. And somewhere in the soft ticking between stars and shadows, you've become part of the ink. The final echoes of the journey settle around you. No more sharp turns, no great mysteries screaming for answers. Just the low, sustained note of understanding. A kind of harmony, deep and steady, playing in the background of existence. You're no longer traveling through the cosmos. You are the cosmos. Not metaphorically, literally. Every atom in your body forged in a star. Each neuron buzzing with the same charge that once lit galaxies. You are the end product of entropy and time and curiosity. You began as dust. You returned as wonder. And in between, you asked some pretty big questions. Like, why do black holes exist? The answer now feels simple. Because they must. Because the universe, like any good story, needs tension. Needs gravity strong enough to make stars collapse and minds open. Needs reminders that time isn't a guarantee, that endings exist, and that even in darkness, especially in darkness, transformation happens. Black holes aren't villains. They're editors. They remove what no longer serves. They press the reset button. They create the silence needed for a new song. And time was never a straight line. It's a texture, rich and unpredictable, sometimes elastic, sometimes stubborn, always ticking just a little bit off beat. You learn to live in it, to stretch within it, to let it carry you through black holes and rebirths and galaxies too vast to name. You remember a quote now, one you read long ago, in another version of you. You used to think that was poetic. Now you realize it's also true. You were never separate from the universe. You are a branch of its thinking, a spark of its remembering. And now, in this moment, wrapped in silence and soft awareness, you feel its full embrace. You're not drifting anymore. You're home. And as the lights of this imagined cosmos dim to a comforting glow, your breath slows. Your thoughts blur. You let go, not out of fear or sadness, but because the story is complete. Not over, just ready for its next version. The black holes still turn, somewhere far away. Stars still blink out. New ones form. Cycles continue. But you? You rest. Because you've seen the dance now. You've heard the rhythm. You've become the music. And in the end, that's all the universe ever wanted. To be known. To be felt. To be dreamed. And you did all three. Wind down. Final 300 words. Let everything soften now. Let your breath ease into a slower rhythm, like waves drawing back from the shore. Let the thoughts fade like footprints in sand. Still there, but no longer sharp, no longer urgent. You've traveled across time. You've stood at the edge of black holes. You've seen stars rise and fade, and felt the stretch of a universe too vast to hold in your mind, yet somehow gentle enough to carry you. Let your jaw unclench. Let your shoulders release their weight. Feel gravity not as a force that pulls, but as a cradle, one that's been holding you all this time. Outside your window, the stars are still glowing. The galaxies are still spinning. And inside you, the quiet remains. Not empty, not lonely, just quiet. A soft hum at the heart of things. If a new universe is out there waiting to be born, it can wait a while longer. Tonight, you've earned the stillness. You've earned the hush. Close your eyes. The story will begin again tomorrow. But for now, let yourself disappear into the dark, not as something lost, but as something found. Good night, little observer. You are part of everything.